In this video, we're gonna solve problems involving sequence, series, and sigma notation. Let's have the first one. Write the first four terms of the sequence defined by a sub n equals 1 over 4 raised to n minus 2 plus 1. So this means that the first four terms can be found by replacing n by 1, 2, 3, and 4. So if we have a sub 1, that would be 1 divided by 4 to the 1 minus 2 plus 1. That is 1 divided by 4. 1 minus 2 is negative 1 plus 1. That is 1 over 4 to the negative 1 is 1/4 plus 1 is equal to 1 over 4 plus 1, that's 5/4. Then 1 divided by 5/4, that is 4 over 5. Or if you want, you can just use your calculator. That is 1 divided by 4 raised to 1 minus 2 plus 1. And it will give you 4/5. Okay, so the second term will be a sub 2, which is 1 all over 4, 2 minus 2 plus 1. And that is 1 over 4 raised to 0 plus 1. We know that any number raised to 0 is always 1. So 1 plus 1, that is 1/2. Okay, then the third term is just 1 over 4, 3 minus 2 plus 1, which is equal to 1 all over 4 to the 1 plus 1. And that is equal to 1 over 5. And lastly, the fourth term is 1 all over 4 raised to 4 minus 2 plus 1, which is equal to 1 over 4 raised to 2 plus 1, and that is 1 over 16 plus 1, and finally that is 1 over 17. So therefore, the first four terms of the sequence are 4/5, 1/2, 1/5, and 1 over 17. How about this one? What is the specific name given for a series with a common ratio and the last term is not identified? Based on the definition, it has a common ratio, therefore it is a geometric series. But it is also stated that we cannot identify the last term. Therefore, this is an infinite geometric series. Okay, so what is the 10th term of a Fibonacci sequence? We know that the Fibonacci sequence starts with 1, then 1, then you add the two preceding terms, 1 plus 1, that's 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, plus 8 is 21, then 21 plus 13, that is 34, and 34 plus 21 is 55. And as you can see, this is the 10th term of the Fibonacci sequence. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Evaluate 3 plus 3 over 2 plus 3 fourths plus 3 over 8. So if we check the difference, they do not have the same difference. But if we check the common ratio, we can see that a common ratio exists. So that is 3 over 2 divided by 3, that is 1/2, because 3 times 1/2 is 3 over 2. So 3/4 divided by 3 over 2, 3/4 times 2/3, we cancel 2, that is 1/2 also. This should be 8, sorry. 8. So 3/4 divided by 3/8 divided by 3/4 is also 1/2. So this is geometric, but we do not know the last term, therefore it is an infinite geometric series. And to find the sum of infinite geometric series, we use the formula S sub n is equal to a sub 1, 1 minus r. So we have S sub n equals a sub 1, the first term is 3, 1 minus the common ratio, 1 half, and that is 3 divided by 1 minus 1 half is 1 half, and finally the sum is equal to the quotient of 3 and 1 half, which is 6. So the sum of the infinite geometric series is 6. Find the sum of the first 30 positive integers. So if we illustrate this, this can be written as 1 plus 2 plus 3 up to 30. Okay? Since this is an arithmetic series, because there is a common difference of 1, and we can identify the first and the last term, we can use the formula S of n is equal to n over 2 times the first term plus the last term, which is a sub 30. So take note that n is equal to 30, the first term is equal to 1, and the n a sub n or a sub 30 is equal to 30. So therefore, s sub 30 is equal to 30 divided by 2 times a sub 1, 1 plus a sub n, which is 30. Then s sub 30 is equal to 15 times 31, and uh, 15 times 31 equals 465. Okay, so therefore the sum of the first 30 positive integers is 465. So find the nth term of the sequence -4, -3, -2, -1, 0, 1. So as you can see, this is an arithmetic because when you subtract -3 and -4, the result is 1, right? -2 minus -3, that is also 1. -1 minus -2 is also 1. Then 0 minus -1 is 1. And this is also 1. That's very obvious that the nth term of this sequence is just n minus 5, because when n is 1, 1 minus 5, so the first term is -4. When n is 2, the second term would be 2 minus 5, that's -3. But if we use the formula for arithmetic sequence, we can verify that it is really n minus 5. Okay, so a sub n equals, first term is -4 plus n minus 1, the common difference is 1. So a sub n is equal to -4 plus n minus 1. And that is n, -4 minus 1, -5. So the nth term is n minus 5. Okay, so for this one, so this is a sequence with identifiable first term and last term. If we can identify the last term of the sequence, this is called a finite sequence. So the answer for this is finite. So next, find the nth term of the sequence 6, 10, 14, 18. So as you can see, if we subtract 10 minus 6 is 4, 14 minus 10 is 4, 14 minus 18 is also 4. So this is arithmetic. And to find the nth term, that is a sub n, equals a sub 1 plus n minus 1 times d. So a sub n equals, the first term is 6, n minus 1, common difference 4. That is a sub n equals 6 plus distribute 4 times n, that's 4n, 4 times -1, -4. So that is 4n, 6 minus 4, positive 2. So the nth term is 4n plus 2. And to find the 100th term of that sequence, we just have to find a sub 100, which is 4 times 100 plus 2. And that is 400 plus 2, or which is 402. Find the nth term of the sequence 3, 6, 1, 1, 6, 1 over 36. So if we divide 6 over 36, that is 1, 6. 1 over 6 is also 1, 6. 1, 6 divided 1 is 1, 6. and so on. Therefore, there is a common ratio of 1 6, and thus it is geometric. The formula for geometric is a sub n equals a sub 1 r to the n minus 1. So a sub n equals, the first term is 36, the common ratio is 1 6 times n or raised to n minus 1. And 36 can be expressed as power of 6, that is 6 squared, times, then 1 6 can be expressed as 6 to negative 1 n minus 1. And therefore we have 6 to the 6 squared, then distribute negative 1 times n, that's negative n, negative 1 times negative 1, positive 1. Multiply the two expressions, then you add the exponent, that is 6, negative n, 2 plus 1, 3. So the answer is 6 raised to negative n plus 3, or 6 raised to 3 minus n. How about the next one? Find the sum of the first 10 terms. So the sum of geometric series, just a sub n equals to a sub 1 r to the n minus 1 over r minus 1. So a sub 1 is 36. Our r is 1 6 raised to 10, right? So 1 6 to 10. Then minus 1 divided by 1 6 minus 1. We can just use our calculator. So that is 36 times 1 over 6, okay, raised to 10, then minus 1 all over 1 6 1 6 minus 1. And the answer is 43.19. Okay, so 43.20. What is the nth term of the sequence 1 7 17 31? So 1 7 17 31. So if we divide, that is not common, the quotient is not common, therefore this is not geometric. But when we subtract, we can see pattern. So 7 minus 1, that's 6. 17 minus 7, that's 10. 31 minus 17, that is 14. Then another subtraction, 10 minus 6 is 4. 14 minus 10 is also 4. As you can see, this is quadratic, right? So quadratic sequence siya. Why? Because the second difference is equal, or differences are equal. So quadratic sequence, so the following rule will be used. So 2a is the second difference, which is 4. So therefore a equals 2, because 4 divided by 2 is 2. Then we have 3a plus b is second term minus first term. The second term is 7, the first term is 1, and our a is 2, so 3 times 2 plus b is 6. So b equals 6. 3 times 2 is 6, so minus 6. Therefore, b equals 0. Then, to find c, that's a plus b plus c equals the first term, 1. Our a is 2, b is 0, then c equals 1. So c equals 1 transpose 2 minus 2, c is negative 1. The quadratic equation, or the quadratic expression, follows an squared plus bn plus c. And finally, our a is 2, so that's 2n squared. Ang b is 0, so we can remove this, then minus c, which is 1. So therefore, the nth term of the sequence is 2n squared minus 1. What is the expanded form of the given series? That's summation of I cubed divided by I squared plus 1 from 1 to 4. So this means that You just have to replace I by 1, 2, 3, and 4 and form the sum. To make it easier, we can just use our calculator. So if our n is 1, or rather I is equal to 1, we can just uh, 1 raised to 3 divided by 1 raised to 2 plus 1, and that is 1 half. So the, the first term of the series is 1 half. Next, can just replace 1 by 2, and the next one is 8 over 5 plus, then we replace it by 3, so 27 over 10 plus, then replace by 4, that is 64 over 17. So this is the expanded form of the given series in sigma notation. So the sigma notation is this one, then this is the expanded form. Next is, what's the value of the given series above? And the value nito. So we can find the value of that by simply adding this one, that's 1 half plus 8 over 5 plus 27 over 10 plus 64 over 17. So the answer is 728 over 85. Also, you can verify the result using the sigma notation. This is our summed here. So this is summed. So we have x cubed alpha x cubed divided by alpha x squared plus 1. So we use x instead of I because this is being used, the default variable in the calculator, from 1 to 4. As you can see, we arrive at the same answer, 728 over 85. Express 1 minus 1 half plus 1/4 minus 1/8 in sigma notation. You can see, if we write it again, 1 minus 1 half plus 1/4 minus 1/8. As you can see, the signs are alternating. And if it is alternating, we need to multiply the expression in the sigma notation by negative 1 raised to I plus 1 when it starts with a positive. But how are we going to find the nth term? As you can see, all the numerators are 1, but the denominator are are geometric, right? We can just put 1 here. So 1, 2, 4, 8. You look at the denominator, that's 1, 2, 4, 8. And this is geometric sequence whose n term is 2 to the n minus 1, right? Because if our n is 1, 1 minus 1 is 0, 2 to the 0 is 1. If n is 2, 2 minus 1 is 1, 2 to the 1 is 2. If n is 3, 3 minus 1 is 2, 2 squared, that's 4. Paano nakuha yan? That's a sub n equals a sub 1 r to n minus 1. So a1 is 1, then common ratio is 2 divide 1, 4 divide 2, 8 divide 4, that's 2. So n minus 1. So that's a sub n equals 2 to the n minus 1. So yan yung n term ng denominator. So we can now find the sigma notation form. That is, the summation of, since alternating, that starts with a positive, we multiply by negative 1 raised to I plus 1 times 1, the numerator, divided by the n term of the denominator, which is 2 raised to I minus 1. Okay? From 1 to 4. So this is the sigma notation form of the given expanded series. That's the summation of negative 1 raised to I plus 1 times 1 over 2 to the I minus 1 from 1 to 4. So write 0 plus 2 plus 6 plus 12 in sigma notation. So we use the concept of quadratic because that's 2, 4, 8, or rather 6. So that's 2, 2. So that's quadratic. So 2a is equal to 2, the second difference. A equals 1. Then 3a plus b equals second term minus first term, 2 minus 0. So 3 times 1 plus b equals 2. Therefore, b equals 2 minus 3. And that is negative 1. Then c is a plus b plus c equals first term. So 1 minus 1 plus c equals 0. Therefore, 1 minus 1 is 0. So c equals 0. The end term is what? Following an squared plus bn plus c. So a is 1. So that's 1n squared or n squared. B is negative 1. So minus 1n or n. Then c. So wala na yung c kasi 0 na siya. So the end term is n squared minus n. Therefore, the sigma notation is the summation of I squared minus I from 1 to 3, 4 siya, from 1 to 4. The summation of I squared minus 1 from 1 to 4. Find the value of the summation of 3i from 3 to 7 plus 1. So, do not be confused on this one. So, the summation of 3i plus 1 from 3 to 7 means that we just need to get the summation of 3i from 3 to 7. Then, we add the result by 1 because there is no parenthesis in 3i plus 1. So, meaning you need to find the summation of 3i only. So, that's become 3 times 3 plus 3 times 4 plus 3 times 5 plus 3 times 6 plus 3 times 7. Then you add 1. So, 9, 12, 15, 18, 21, plus 1. And if you do that, the answer is 76. We check. So 9 plus 12 plus 15 plus 18 plus 21 plus 1. Three, 4, 5, 6, 7. So we check again. So 9. Sorry. 22 here. That should be 12. So yan. 12 dapat to. So 76. So if you're going to do the summation in your calculator, you can express this as sheet 3x from 3 to 7, then plus 1. So 76. Express negative 1 plus 8 minus 27 plus 64 minus and so on in sigma notation. So alternating sign, and it starts with a negative, therefore we multiply the summation by negative 1 to the I. But look at the terms. We have 1, 8, 27, 64. What do you notice in that? We know that 1 can be found by cubing 1, 8 can be found by cubing 3, then 7 can be found by cubing 3. Add for this cubing 2, sorry, that's 4 cube. So, this means that the end term is I cube, right? But, alternating yung sign, so, we start by multiplying negative 1 to the I because negative yung start times I cube. From 1, then the last term is not identified, to infinity. So this is the sigma notation. Negative 1 to the I times I cube from 1 to positive infinity. Arithmetic sequence, common difference, geometric sequence is what? So very simple, that's common ratio. An auditorium has 22 seats in the first row and it has 36 rows in all. Each successive row contains one additional seat. How many seats are in the auditorium? The second statement tells that the series here is an arithmetic because each successive row contains one additional seat. There is a common difference of 1. So if we find the given here, auditorium has 22 seats in the first row. That's the first term. That's 22. And it has 36 rows. So on total, the number of rows ay 36. And the common difference is 1. We are looking for the total number of seats in the auditorium. So we can use the formula S sub n kasi arithmetic siya. And we do not know the last term. So n over 2 times 2a sub 1 plus n minus 1 times d. That's S sub 36. That's 36 over 2. Then 2 times 22 plus 36 minus 1 times 1, the common difference. Okay, so S36 equals 36 over 2 is 18, 44, 2 times 22 plus 35. So S sub 36 equals 18 times 4 plus 3, 7, 4 plus 5, 9. 18 times 79. 1422. So, 1422 yung total number of seats. Okay, so I hope you learned something in solving problems involving sequence, series, and sigma notation.